And welcome back to All This Math. This is Professor Parker, and today we're going to do a little algebra. We're going to graph a linear inequality. All right, a linear inequality. Okay, when you first see a problem like this might seem a little intimidating to you because of the inequality sign. You might be used to just graphing equations, right? But I'm going to show you how we graph linear inequalities is very much connected to how we graph equations. All right, so first let's read what the original problem is. This says that y is less than or equal to, right? That bar means also or equal to, less than or equal to 3/5 x minus 5. All right, that's what this means. Now, here I drew my little, it's not perfect, but, it's cool. I drew my little XY coordinate plane. That's my x-axis. This is my y-axis, vertical axis, horizontal axis. All right, I'm going to draw a line on here. And actually, when we graph inequalities, it's not just a line. There's going to be a shaded region, too. You know what I'm saying? I'm going to show you. It's going to be a shaded region. So first thing you do is, and this is not that difficult, right? It's very similar to how we graph linear equations, okay, with just some slight differences that I'll get into. First thing you want to do is I want to treat this like it's an equation, though, because I want to draw what's called the boundary line, because we're going to have to do some shading, right? So it's kind of like art. It's kind of like, like a little art project. You're kind of drawing something. You're going to shade, you're going to draw your boundary line, and then you're either going to shade below it or above it, right? No matter where the line is. So first thing we need to understand, in order to draw our boundary line is, I need to know what my y-intercept is. Your y-intercept is like your home address. That's where you're starting from, right? That's your location on this graph where you are. And it happens to be on the y-axis. So this number right here is your y-axis, right? This number right here, this -5. So you're going to say B is equal to -5. All right? I like to just identify all my important pieces of information. That's why I wrote it out, knowing that it's right there. So B is equal to -5. So then I go on this graph, and I'm going to switch up the color, right? So to stand out a little bit. So on this y-axis, I'm going to find -5. Now, the negatives are not up here, so you shouldn't be putting no points up here nowhere. Your point is going to be down here, right? So this is the origin. So this will be 0, 0. So then you go 0, -1, 0, -2, 0, -3, 0, -4, 0, -5. Boom. That's your y-intercept right there. Your y-intercept is right there. That's like your home address, right? That's where you start from, okay? Now, the next piece of information we need is my slope. My slope is always the coefficient of the x term, right? So that's going to be m. We use m to represent slope. M equals 3/5. And slope is very important, just even as a concept, because once you get to calculus, you're going to see how important slope is. So make sure you have a full understanding of slope in your Algebra 1 class or your Algebra 2 class, or whichever class you're doing this in. So the top number, you probably heard the phrase rise over run, right? The top number in the fraction tells you how far up or down you're going, right? If it's positive, you're going up. If it's negative, you're going down. The bottom number tells you how far you're going left or right, horizontal. So since this is positive, this is what I like to do. And I recommend it to y'all, but you don't got to do it if you don't want to. But I like to do arrows. So because that's +3, that's telling me I'm going up 3 spaces. So I like to do arrows. That's just one of my little idiosyncrasies that I use when I'm doing math problems. For the bottom number, it's also positive. So I'm going to do an arrow to the right, +5, right? If it was negative, I would have an arrow facing that way. If 3 was negative, I would have an arrow facing down, just to kind of remind me, okay, where I should be moving. Now, 3/5 is not a point. 3/5 are directions from your house. Remember, you start at your y-intercept. Now, this tells you how to get to the next point or how to get to your destination since you're going somewhere else, right? So that means I'm going to start at this point and I'm going to go up 3 spaces. 1, 2, 3. And then I'm going to go to the right 5 spaces. 1, 2, 3, 4, 5. Then I stop there. That's why I draw my point. I draw my second point right there. Right? Draw my second point right there. So I got 1 point and 2 points. I got 2 points. So now I'm good. I'm good because I need a minimum of 2 points to draw a line. And this is going to be my boundary line, right? My boundary line. So now I'm going to try to make this line as straight as possible. I kind of eyeball it. Okay, there we go. Now, one thing I do want to point out with linear inequalities, because this is equal to or equal to, it's going to be a solid line. If it was only less than, this would be a dashed line. So if it was only less than, it would be a dashed line. But because it's also equal to, that's why it's a solid line. Okay? Now, this is our boundary line. Now, the next step and the final step is to show where we're going to shade at. Now, this is how I do it. This is one of the ways to do it, right? I like to think of y represents the shaded area. So y represents the shaded area. The 3/5 x minus 5 represents the boundary line. Represents the boundary line. So if the shaded area is less than or equal to the boundary line, we got to think about this like intuitively, right? And apply some common sense here. So if the shaded area is less than the line, does that make me think that I would shade above the line or would I shade below the line? Because this is telling me that the shaded area, which is represented by y, is less than the line. If something's less than, it's beneath it, right? Like if we both take a test and my score is less than yours, that means my number is less than your number. My number is below your number. So that tells us that we're going to shade underneath of the line. And that, my friends, is how we graph a linear inequality. We just shade underneath. This marker's no good. Let me get rid of that. Boom. Let's see if this marker's better. This marker ain't really no good neither. I need to re-up. All right, but anyway, you get the point, right? It's shaded underneath of the line. Another way, real quick, another way to tell which side of the boundary line you should shade on is pick what's called a test point. A test point. Now, unless the line goes through the origin, we can use the origin as a test point. So let's do this. Let's use 0, 0, which is the origin, as a test point. And we want to see if it's a true statement. If I substitute in 0 and 0 for x and y, and it gives me a true statement, then that means that 0, 0 is a solution. Now, if 0, 0 is a solution, which is right here, that means everything else with 0, 0 on that side of the line is also a solution. Everything else too. Now, if 0, 0 is not a solution, that means that not only is 0, 0 not a solution, that means nothing else on this side of the line is a solution. Which means that everything on the other side of the line is a solution, like we got down here. So watch what's going to happen. I'm going to replace y with 0. Right there. I'm going to do my 3/5. Boom. Replace the x with 0. Boom. Minus 5. Boom. Now, 0 is just 0. There's no math to do on the left side. But on the right side, I follow order of operations. I do 3/5 times 0. That's going to cancel out and becomes just 0. 0 minus 5 is negative 5. Now, is this a true statement? Is 0 less than negative 5? Nah, 0 is less than positive 5, but 0 is not less than negative 5. 0 is greater than negative 5. 0 is greater than every negative number. So therefore, that means that this point right here is not a solution. And if this point is not a solution, nothing over here is a solution. And if nothing over here is a solution, then it means that everything on this side is a solution. So there, I just gave you a couple ways to tell where to shade at. Because that's one of the major challenges students have with graphing linear inequalities is where do I shade at? How do I know where to shade at? I might know how to draw the boundary line. That might be cool, but the shading part, I don't know. But I actually prefer thinking of y as the shaded part and this part, this expression on the other side of the inequality as the line. And then we kind of just think critically and think about, well, what does that mean? If the shaded part is less than the line, doesn't that mean that the shaded part is below the line, right? So we gotta, whenever we're doing mathematics, we gotta always try to apply common sense and critical thinking at all times, you know? So if this video was helpful to you, please go ahead and hit the like button. Also share the video, send it out to somebody, let somebody else know about it. You know, let's let people know what we're doing here, all this math and what we're trying to accomplish and providing this mathematics resource for students, parents, teachers, whoever needs it, you know? And as always, do remember that there's all this math all around you. Peace.